Well, I thank you guys for coming and for inviting me to begin with. Start off this AWG lecture series. This is a great idea, and I'm glad that I am able to participate. So, really, what I wanted to do today was just talk about kind of my path and how I have navigated to the place that I am today as a geoscientist. And so, you know, I hope that this can be useful for some, because I think that this is kind of a statement I got a lot early on. So you want to be a scientist, sort of a question, a little bit of confusion. I was the only scientist in my group of friends, and so I think it's at least in undergrad, and so I think it's something I just sort of wanted to kind of, like I said, follow the path I navigated, the good things and the bad things, and as I say, buckle up. You're in for a wild, but what I think is a worthwhile ride. So it's we're gonna follow on this theme of a ride, and we're gonna go for a road trip. So I grew up in Memphis, outside of Memphis, Tennessee. One of 5 kids who all played soccer. So much of our family vacations, if you can use that term, were they were either soccer tournaments or they were camping trips. And so just from the off, much of my childhood was spent in the great outdoors. And I think that really instilled in me a love for nature and an appreciation for nature and the environment, and I think that's kind of carried me through a long kind of a winding path that first began by moving a little bit further east to sort of central eastern Tennessee, where I went to undergrad. So right here we were basically on the very edge, western edge of the Appalachian Mountains, at a small little liberal arts college called Sewanee, or the University of the South. So here's just an image of the campus, and that was, I think, the biggest part of this experience was this campus is about 13,000 acres. And so much of my time was spent still playing soccer. That didn't leave my life until I graduated from undergrad, at least not in a formal setting. But the rest of it was spent in labs outdoors. So I went to school thinking that I wanted to be an English major. And I had to take a science class, and I had to take a lab class. And I didn't want to be stuck indoors. And given that the fact that we had 13,000 acres, geology class meant that I could be outside for all of my labs. And I think that not until many years down the road that I realized that was an unusual thing, that every week we would have multiple labs outdoors. And, you know, just from the off, very comfortable with navigating that landscape. And like I said, I didn't realize until later that, you know, the time we spent either on the campus or here in Georgia on field trips, or in the West and Southwest on field trips, or even in Germany on field trips, that was an incredibly unique and privileged experience that I had to just be so comfortable in that setting. And so in my mind, that's what geology was to me. It's still to some degree what geology is to me. this was followed by, or also kind of broadened to include several experiences in terms of undergraduate research. And I don't think I can kind of reiterate how important that getting that undergraduate research experience for me was, and I think for many students can be, to take me again kind of out of my comfort zone, or this time to start taking me out of my comfort zone. So the first kind of research experience I got was doing a water quality study on a shallow barrier bar island or a barrier bar island, St. Catherine's Island off the coast of Georgia. And we were studying the shallow aquifer there. You can see in the middle picture, there's a landfill and dump that had pretty much been in existence on this island for hundreds of years. And we were trying to determine if it had water aquifer. And then the kind of next experience was a research in Green Lakes Valley in the Front Range of Colorado. Here I was, so this is a glacial valley, and looking at, you can see kind of this landscape of fractured bedrock, and I was trying to determine how the patterns and density of fractures controlled the glacial erosion that went through this area. So this was part of a critical zone study, critical zone observatory, kind of very early on in the first iteration of the NSF grant. That of course several of the UTEP faculty are now involved with as well. I think that one thing, again, to some degree, I lucked into this. I had advisors. You can see my advisor here in the top images that really advocated for me and advocated for me to do this work. And so I don't think that without that support from a mentor, from an advisor, that I necessarily would have reached out for these experiences on my own. But I'm grateful that I did. This also eventually led me to apply for a Fulbright scholarship. So now we're going to venture out of the U.S. and I spent a year living in Germany, just outside of Munich, Germany. But it actually also ended up taking me to Athens, Greece as well for some time. So here. And just to clarify this title, if you're not familiar with Mark Twain's work, this was a Tramp Abroad was one of his books that he wrote. So that's not me defining myself. That is a tip of the hat to a book that I read for a good portion of the time while I was living there, his experiences in Germany and learning the German language, which is difficult to say the least. But here I was doing some field and lab work, mainly in the realm of geoarchaeology and shallow subsurface geophysics. So we were trying to, for the most part, interpret buried archaeological sites. So here's kind of one of our setups using some shallow subsurface geophysical techniques where we were taking this across essentially what's a agricultural field today. But what I think is kind of the most unique part of this experience was getting to take this to Greece, to Athens, and in fact just to the base of the Acropolis. So there's the Acropolis up there at the top in this middle picture, and here I am at the base. We're setting up electrical resistivity lines here. We're running ground penetrating radar in the upper right. So various non-invasive techniques to try to determine if there was, so I should step back. On this image on the right-hand side, you can see this kind of bricked off green patch. That is one very old pit that had been excavated, I think, several hundreds of years ago. Under the glass cover to the left of that is a relatively recent pit that had been excavated, where they found, in both of those two, they had found the evidence, or where the statue of Athena, this really elaborate statue that used to stand in front of the Acropolis before, I'm forgetting which invading group destroyed it, but it was a huge, 20, 30-foot statue of Athena that had been cast in these pits that you can see two of them right here that were basically along the pilgrimage path up to the Acropolis. So after they would use the pit to make the cast or make the statue, they would fill it back in, because this was, a regular pathway for people in the community. And so these pits have since been excavated, and they found everything except for where the head was cast. But on many old maps and things, there was indications that there was another pit right here, just to the right of it. And that's what we were trying to find out. We were doing these, like I said, non-invasive geophysical techniques to try to determine if there was a buried archaeological site there. And at least what our data suggested was that there was. And this has now been well over a decade since I've done this work, and I have no idea if they actually ever went back and excavated that. But this was sort of another kind of flavor of geology that I got in this moment. And you'll notice that I've gone now from groundwater, studying groundwater quality. That's actually what I did. I worked as an environmental consultant while I was an undergrad as well, on the kind of holiday breaks. And then to structural analysis and critical zone work, now to geoarchaeology and geophysics. And through all of that, while I didn't stay in any of those fields, within any of those subjects, I think what it did was really expose me to all of the different ways that geology can be applied, that the geosciences can be applied, that go beyond, I think, what perhaps a public perception of geology as an extractive, exploitive industry. And so these are things that, while I, like I said, I haven't stayed within these fields today, it's experiences that I'm able to share with my students that just really, I think, show how broadly the geosciences can be applied to our understanding of the entire Earth's history, whether that be the most ancient, Precambrian, to simply the prehistoric or kind of early human civilizations as well. Okay, so let's see, where are we headed next? I spent a little bit of time after that fellowship, after that Fulbright, not knowing what to do, not being ready quite to go back to school. So I worked for a little bit of time. I spent some time in Chicago, again, working for an environmental consulting firm. I spent a little bit of time teaching 7th and 8th graders, and quickly learned that middle school was not my cup of tea. But eventually I settled on grad school, and that I wanted to kind of further my education several years later, beginning first at New Mexico State, and very quickly making my way down to UTEP. As I said, I actually went to grad school at New Mexico State, and I went there specifically to work with Kate Giles, who's now at UTEP, of course. And I showed up on the first day, and she said, "I have a bomb to drop on you. I'm leaving." I just moved across the country with everything that I owned, with virtually no money in my pocket, and thankfully it was simply to move down the road to UTEP, and in the end this was the best situation that ever could have happened for me, where I ended up spending the next nearly a decade, and where I dearly miss today, is El Paso and the UTEP department, where not only was I able to do my master's, which is what I had gone to New Mexico State to do, but I decided to take it as a sign when we moved to UTEP, and there was a PhD program where I could continue my education and go into teaching, and that's ultimately what I've decided to do, or what at that time I decided to do. Kind of the kind of unifying theme between all of that is the group that we were working with, or the research group that I am a part of still today, even several years later, and have been since the early 2010s, the Salt Sediment Interaction Research Consortium at UTEP. And so right now, most of this is a very non-technical talk, but I do kind of want to share a little bit of the work that I do now. If you'll humor me for a moment to listen to a bit of technical talk, where my journey has taken me again back to Europe, to Spain, as well as to Australia, and even up to Colorado and Utah, kind of the Four Corners region, as an ancillary location. I'll focus on Australia and Spain first, where so what I work in now is salt tectonics. So I'm a sedimentologist and stratigrapher now. Like I said, I've got a little bit of a flavor from those earlier experiences, and ultimately settled on sedimentology and stratigraphy and salt tectonics. And so just to kind of give some background, when we talk about salt, it actually includes a lot of other evaporite lithologies as well as non-evaporite lithologies. So, salt, of course, is just pure halite, or true salt. Rock salt is halite, but you've got gypsum, anhydrite, sylvite, all kinds of other weird evaporite lithologies. And then anytime salt is deposited, this kind of loose term of salt, it ends up being as this layered evaporite sequence of both those evaporites and non-evaporites. So anything that's sandstones, or just kind of siliciclastics in general, carbonates, even mafic igneous rocks that are deposited in a sequence with salt. But ultimately, the halite is really important for a couple of different reasons. One, it's mechanically weak, and so it deforms viscously, basically as a viscous fluid that flows over geologic timescales, and it's relatively constant density regardless of its burial depth, so you can't compress it. And so what ends up happening, if you take a look at the diagram on the right hand side, is that anytime you develop a differential load, a kind of a difference in pressure above salt, that's going to cause your salt to flow. So here's an example where we're developing this differential load by basically extension. We're pulling this, in black is our salt, and we're pulling this system apart. And notice the kind of yellow arrows that are showing you how, in response to that, from the outside parts of these figures where there's a thicker section of overburden, to the inside part where there's a thinner section of overburden, the salt flows into that relative low in terms of differential pressure. And so it rises, and anytime that happens, if it makes it to the surface, it can basically remain there as sedimentation occurs kind of around it and above it, and continues to, basically you add sediment in these sections here, causing those what we call mini basins to sink and drive salt to rise here. So one important thing about that is that salt doesn't drive salt tectonics. It simply facilitates, and it reacts passively to these external forces. In this case, extension. You can do it also with compression, or you can do it entirely with kind of sedimentary loading. So there's a number of different ways to do this and make salt react. And so for this and several other different reasons, salt tends to be lost from the geologic record. So you can lose it by dissolution, it can migrate somewhere else, it can be eroded, etc. So most of the time, the salt itself is actually a really crummy record of the history that it has undergone. So the best geologic record is actually in the strata, the overburdened, what we call gross strata, that are deposited on top of and around it, those that I was talking about before. And I've got just kind of a schematic on the left and a seismic profile on the right-hand side, giving you some ideas of the various different types of gross strata that tell us a little bit about the history. On the right-hand side, the salt is the dark gray, and the gross strata is the white. And then on the I said the right-hand side, the left-hand side, excuse me. And then on the right-hand side, on the seismic profile, the salt is here in blue, and then all of the gross strata are in these various different colors. This can vary. This type of gross strata can vary from the kind of smallest scale, what we call halokinetic sequences. It's these guys right up close to the diapir, where they're thin and they're upturned and they're all bound by unconformities, these little stratal packages, very close to the diapir, less than a kilometer. Or we can be talking about these huge, basically large scale folds that we call megaflaps, where you get this deepest stratigraphy that it goes all the way up the flank of this steep-sided salt diapir, and this kind of near vertical to overturned panel. So we've got things that are very small scale to very large scale, and they can all tell us something a little bit different. So just to kind of give you an idea of what that included in my work, the example that I mentioned from Australia, looking at this is just from the PhD. I also worked down there for my master's as well, but this Wichelina diapir that we've got here on the left-hand side, where I was basically characterizing the evolution of these two basins on either side, this megaflap on the left-hand side, that evolved during passive salt diapirism, and seeing that, or recognizing that how strongly that controlled the sedimentation patterns on the basin and both the basin and mini basin scales. So kind of, again, small scale and large scale, where this megaflap formed very progressively as our diapir rose gradually. In Spain, there was an addition in this case of not just the sedimentology and the stratigraphy, but adding the component of structural geology. So for those of you that are working on your PhDs or have worked on your PhDs, you recognize you're always, you're supposed to, at least what I was told, was add a component, and that's where the structural geology came in. Here, trying to reconcile two megaflaps that we have here and how they formed. There's two very different interpretations, that's a gravity-driven extension or passive salt diapirism. Trying to use sedimentology and stratigraphy to reconcile the structure, basically, which is something that's even still in the works today. So it's not moving ahead. There we go. So that's the science behind grad school, but I think that it's very important to recognize that in every single one of those scenarios, I was so far out of my comfort zone, and it was terrifying. And so, if I can add kind of one caveat to all of that work, is all of these experiences is, going abroad, or even just simply going into regions of the US that we're unfamiliar with. They're going to be in many cases scary, daunting, maybe is the better word to describe it. But what I would say is, you know, be afraid, but do it anyways. Because in the end, I recognized that it has taught me so much. But at the same time, you know, you don't want to just survive grad school. You want to thrive in grad school, and these are the experiences ultimately that gave me that. And it's the people, and it's the people that I miss the most in terms of El Paso and all of the experiences that relate to that. All of these different people that have supported me, that I've spent, you know, hours around the campfire or in the lab or on field trips, etc. And that is ultimately the part that is most important to me now, and that I miss the most. So never forget the importance of having those people around you. All right, so the last kind of couple of slides here is just what's happened. What next? How did I go from UTEP, working with kids in Wyoming, eventually to a position at New Mexico State? So I had 30 applications in 2 years, 30 job applications, and 9 interviews. And ultimately, the biggest thing that I dealt with in that was the no's and the rejection, and that is a very difficult thing that I think we all need to acknowledge, that it's not easy if you choose to go into academia, as I have. I was lucky enough to get one offer shortly after my graduation to teach at New Mexico State. And then ultimately to where I am today, in my second offer. So 30 applications, 9 interviews, and 2 offers in the course of 2 years. But luckily I've found a landing spot. I'm now at Utah State, in the College of Science, and I'm actually based at the Utah State Eastern Campus here in the geology department, or I am the geology department here at Utah State Eastern with the book cliffs. So this is my backdrop. And as a sedimentologist, this is a perfect place to have landed. And I'm incredibly grateful for that. But I also want to acknowledge that for anybody that's going into teaching, and looking for tenure track positions, as I have been over the last couple of years, that it is a very difficult journey to take. But ultimately, I think that I'm glad that I've done it, and I think I'm glad I've ended up where I have after many different various heartbreaks of not getting what I thought was the job that I wanted. And one of the reasons why is because I found a place where I can hopefully actively make a difference. And this is, I wanted to kind of promote this group, URGE, Unlearning Racism in Geoscience, that is a world, or I think it's worldwide at this point, trying to increase the diversity, equity, and inclusion in the geosciences. And I think something that another thing that I would take away from my time at UTEP is how beneficial those things can be for the science, and that we are, hopefully making progress in terms of diversity in the geosciences. And I'm glad that I've found a place that I can kind of work on that with other like-minded people. It was a rambling journey. it was a wild journey, but thank you for following along, and happy to take questions in our last couple of minutes.
That was super awesome. I mean, I still think you're awesome.
Well, thank you. I don't know. You know, I am very, I appreciate that you know, that you wanted me to come in and give my experience, but I'm figuring it out myself. So, you know, I think that that's something that we can all recognize. We can all appreciate that. Just because you've graduated, or just when you graduate, you don't have it figured out. It doesn't mean anything other than you were able to get it turned in. And then it's time to figure out what comes next.
Yeah, I think that's great advice. Does anyone have a question for Evey?
Yeah, I had one little question. I know you had mentioned, I guess, the challenges of a grad student and things like that. And I think we all somehow feel, or we all get that imposter syndrome. Do you have any tips on kind of getting over that and things like that?
You know, I was hoping maybe some of y'all could give me some. I suffer from that every single day. And I have, and I don't, what I would say is, find people who remind you and remind you that you are not an imposter. You know, even in prepping for this interview, or for this interview, for this, and I see that we're about to lose it. So Kat, I'm happy to get back on, but I got in touch with Amanda and Claire and got the same response then that I would have gotten 5 years ago, that you know what you are doing, and find someone that reminds you of that, because it truly helps to have someone else to support you. And that's how I've dealt with it. Dealt with it being a very loose term there. Man, the imposter syndrome thing is so difficult. You know, I don't know what a solution is to that, other than, you know, a personal solution is to that, which is why I really depend upon the kind of support system around me, because, you know, I think anytime if you're just thinking on your own, if you're in your own head there, it's really hard to get beyond it. But if you get a perspective from someone beside yourself, I think it can be helpful. Just, you know, other people who can take a bit more of an objective view than you can about it, and that makes a world of difference, I think. But, you know, I know faculty who are still dealing with it, and they've been teaching for decades. So, you know, I think you learn to not let it get you as much.
Yeah, definitely.
I don't know. I wish there was an easy solution to that. But I don't know what it is. I haven't figured that one out yet, if there is one. So.
Cool. Eva, did you have any questions?
Just, you know, out of curiosity, what would be the most interesting experience, or the most interesting, I guess, object that you have found while you're in the field?
Ooh, most interesting experience. This is going to be really, a really odd one, but I accidentally scared a kangaroo to death. This was my first time in the field in Australia. When I was working on my master's, and I came around. We were all walking around this outcrop, and I came around an outcrop, and all of a sudden I looked up, and there was a kangaroo standing right in front of me, and I was terrified. And it had been, I guess, in a little cave in the base of this outcrop, and with hearing us, it had jumped out, and I just kind of sat there because never been down there. I'd heard all these stories about like boxing kangaroos and things like that, and so I just kind of slowly backed away, tried to be as quiet as I could, and then we were walking back later on that day, and there was a freshly dead kangaroo on the ground, and kind of put two and two together, realized how close we were to the spot that I had spooked it earlier. And I mean, it was still, it had died, immediately after that. It was really awful. That was a bit foreboding, I think, for my field work to have, I guess they go into caves to, or like the hollowed out gum trees and stuff to die, in peace, like when you've got a dog that ventures out into the wilderness or something. And it was just trying to die peacefully, and I scared it to death.
For you.
Wow.
Yeah. I think that's probably the most interesting experience that I've had in the field. Definitely.
Definitely sounds like it.
I just had one question, Evey.
Yeah.
I think for students like from El Paso or like smaller cities, it's sometimes hard for them to leave, like to take those chances to like leave completely abroad and like leave their family. And I know like for me, that was one of the biggest things that kind of made me hesitate to apply for things. But can you talk about like why that's important?
Yeah, and I think that's at the beginning kind of what I was trying to get at. I probably didn't kind of bring that back around, but I was incredibly lucky in that just, my childhood experiences made me very comfortable with that. And I think that's something that we need to recognize in the geosciences just in general, that's not the case for everybody. And that comfort that was there for me in, going to, being in the outdoors and et cetera. That's not a built-in thing that we can just assume that all geoscience students have. And so we need to build that. We need to, we being myself as an instructor, that's something that we are really, it's a kind of part of that urge group that I was speaking about, is like, how do we make these geoscience experiences things that are not anxiety for students, that they are enjoyable for students, or that they're learning experiences for students. And so I would say, that, yes, and then kind of going beyond that, like, yes, I did do that first, that year I spent in Germany. And even I would say every time I've gone out of the country to do field work, there are moments of panic. There are moments of not just moments, but there are long stretches of time that are just, pure, anxiety just takes over entirely. And so I don't know how, I guess I can kind of speak for myself as an educator, that's something that I am trying to recognize, that, building students up to those big experiences, not just throwing them in the deep end, right? Because if me, someone who spent a lot of time in the outdoors and spent, if I was uncomfortable in some of those situations, then what about people who are not as comfortable from the start? And so, I think that I don't necessarily think that that's on the students to figure out. I think that that's on like us as educators to figure out how do we build students up to those big experiences. And I think in a way, like UTEP, I never realized this until later on, but in a way, the way UTEP does their field camp can help with that, because it's, I think field camp, for instance, is a terrifying thing for a lot of people, because you're out in the middle of nowhere, you're with all of these people, the dynamics can be very stressful. And the way UTEP does it, and I don't know whether this was intentional or not, but just, having kind of blocks of, a 1 week trip, and then you come home for a short period of time, and then you go a little bit further, and then you come back, and a little bit further, come back. That's the kind of scaffolding of experiences that we can give students to make them grow into that comfort zone, right? Like grow into being able to handle those things. Now, that being said, obviously, like, teachers can't do everything. Students have to do some of it. And that's why I really do, I look back at a lot of those experiences, and I think about the anxiety that they gave me, or that the anxiety that they led to, or exacerbated. And it really did. It sent me to the hospital at one point in time. And that's kind of traumatizing for people, for students. I also look back at it, and I don't necessarily think I would change it, as odd as that might sound. And that's why I would say, be uncomfortable a little bit, but try it anyways, because I think you will grow from that. And I think I grew from that. I think that not just scientifically, but I think also just culturally, for myself, that I think that, knowing kind of where I grew up, in a very conservative town in Tennessee, that if I didn't take those experiences, I would be a very different person today. I look back at people I went to high school with, and I know that I would be a very different person today if I hadn't done that. And so I look back at it, and I have to be grateful that I did, because it has opened me up to so many different perspectives that I didn't get. And I think that's why it's worthwhile. But it is hard. And I think that we need to acknowledge that. And we, being students, being educators, everything, that we need to recognize that students that are doing that need the support to do it. And I think educators can give that support. We can help kind of build students up to those really big, life-changing experiences, but we can't expect students to do that just right off the bat. And I think that's another way that kind of my time at UTEP has really shaped how I understand students today, that it is a very different experience than I had. And that I was incredibly privileged to have had that experience, and it's a privilege that not everybody gets. That, so it needs to be it needs to be acknowledged and give the support we can to build students up to their full potential. I really do. I miss El Paso every day. And just like the I lived there for a decade. That was the longest I'd lived anywhere for a long time. And so, it stays with you. And particularly the experience, that's like all of the people that you've been in the trenches with. And like I said, I called on them again for this, and and got the same exact response that I would have gotten 5 years ago of, and that's what that support system will always provide. So